Hi, welcome to the series of lecture on simple machines. This is the first in the series of videos, and this is an introduction. In this video, we look into what is a simple machine and look into common terminologies and understand what is a mechanical advantage and velocity ratio. So, what is a simple machine? Let's first look at a set of examples of what is a simple machine. So here you have a lever. An example of a lever would be scissor. We will see how scissors are examples of a lever, or a cutting plier, etc. Right? Pliers, etc. Right? Crowbar and stuff like that. Seesaw. And another common simple machine is an inclined plane, and in inclined plane there will be screws are a type of inclined planes. So screws are a type of inclined plane which is again a simple machine. It's the most simplest of all machines. Any machine that you take is made up of these simple machines, right? A wheel and axle that has changed the world, the way we live and the way we do transportation, move from one place to another. And then you have the wedges, and wedges are used to split open your wood or kind of nail and stuff like that are examples of wedges. And then your pulley. So in a very common sense, common definition for a simple machine would be a simple machine is a subset, is a mathematical form of subset of a complex machine, right? So all complex machines are made up of simple machines. Complex machines are made of simple machines. So that is the first thing to keep in mind. And the second thing is simple machines don't store energy, right? Don't store its own energy. So there could be many definitions, but these two could be a very basic definition for what a simple machine is. In this series of videos, we are going to talk about two kinds of simple machine, and one is we are going to talk about lever in great detail, and we are also going to talk about pulleys. Next, we are going to understand some terminologies of simple machine with lever as an example. This is a very common simple machine, which is like a crowbar, and here in this you're using this point. This point is called a fulcrum, right? You're using a fulcrum, and this is called fulcrum. A fulcrum is a point where you rest or you pivot your tool. So this is going to rotate around this point, and this here is your load, usually represented by L, and here is your effort, and effort is usually represented by E. So your load is like this, and your effort is like that, right? And this distance that you see from the fulcrum is called, it is the length of the, or in this you have to draw at an angle. So this length is the length of the effort arm, which we represent by LE, and this is the length of the load arm. This is the length of the load arm, right? And so you have fulcrum, length of effort arm, and length of the load arm. And the other term that we use is the distance moved by the load and effort. So let me draw a different diagram for you. So this is the equivalent of that diagram. So as I put in the effort here and then the load here, right? And as I try to put in more effort, the load is lifted up, So the load goes over here, and this height through which you have moved the load is called the distance moved by the effort arm, and this length here is the distance moved by the load arm. So this is the distance moved by load arm, and this is your distance moved by effort arm, right? And this is your length of the effort arm, and this is your length of the load arm, and that's the fulcrum. So here is a summary of all the terminologies we are going to use. We're going to use the term L, which stands for the load. E stands for the effort. LE stands for length of effort arm. LL is length of load arm, and your DE is distance moved by effort, and DL is distance moved by load. In the next video, we are going to talk about these ideas of mechanical advantage and so-called the velocity ratio, what it means in the context of a simple lever.